Hello everyone, welcome back to my channel. In this video, we are going to improve the data sets by data augmentation. So if you remember in the last video, we tried a deep learning model and a data with a very few images, and the results were quite pretty bad. So today we are fixing this problem using data augmentation. If you are new here, we are working on a Sudoku project. You can check out this corner for more details. Alright, if you are ready, don't forget to subscribe, give me a like if you enjoyed the video, and let's get started. So here we are in a new notebook that I have created, where we are going to do the data augmentation. So first of all, the importation of the libraries are basically the same: CV2, NumPy, PlayPod, and OS. We will also need data directory, which is in the C drive and image folder. As you may remember, it is right here where we have the sample images. And then we have the categories, so all the folders that we have inside the img folder. So now we have the definition of the data augmentation. So we loop through all the folders here and we get the path and the class number. So the class number is basically the number of the file. I could have said, for example, integer category to get the integer from the strings, but I prefer to stay simple and use the index instead. And then we are looping through all the images inside the subfolder. Well, obviously, I don't really need to loop through all of them because I only have one image per folder, but we always want that in case if we have multiple images. We never know. Then we have the image array. So it is equal to cv2 imreads os path.join path and image file name. So we are reading the image into the folder to get the array. And then we have the plt imshow, imarray, cmap gray, and plt.show. So basically, we are just displaying all the images that we have in the datasets, which is very little. So we run all of them. Okay, so we have the empty cell 1, 2, 3, 4, 5, 6, 2, 9. Okay, so now we are ready for data augmentation. But before the data augmentation, let's look at a very important point. A very big thing that will make a massive difference is to, instead of getting the raw image itself, we actually need to find the contours of the digits and not just the whole image only. Because let's say one image has the number 1 slightly on the right and another one is slightly on the left. Well, as humans, we see that they are the same, but for a computer, there is a massive difference between them because every pixel matters. So instead of getting these raw images, we are getting the contours images to have a better match. This seems to be very little and obvious, but actually it saves a lot of data and time. I remember when I didn't pay attention to the contours when I first did this project, I had more than 10,000 images and it was not even enough. So I would strongly recommend that you get the contours of the digits. Right, let's continue then. So we can comment these lines out. So before getting the contours, we need to have an image kenny equals to cv2.kenny. So we put the image array and 50, 50. And next we have the contours and the hierarchy, which is equal to cv2.findContours. In here we are passing the image kenny and cv2 chain approximate, all capital obviously. Okay, now we are looping for each contours we find. So for C and T contours, we want to define the area first. So equals cv2 dot contour area. And then you pass this variable inside and true. Then you can even print the area if you wish, but we are not going to do that now. Then we do if area is greater than 5. Well, 5 is quite a low number from the area, but they can be very low when having digits in small images. Then we need approx, which is cv2.approx poly dp, and the contours. So 0.02 times Perry, and we set that to true. And obviously I have noticed that I have forgot to define the Perry, it will not work. So equals to cv2 dot arc length of the contours itself. Well, there is another mistake here. In the area thing, you must not have the true. It might work, but I prefer to avoid it because I do not have. Right. Okay. So these are basically the thing we did in the contours tutorial. So if you, but I'm going slow because I did not share you yet the snippet codes. So that's why I am reviewing this step again. CV2. Now we need to do the bounding rectangle. Actually, we don't need the whole rectangle, just the rects. Approx. So now we have the coordinates. Suppose that you have an image like this. So x is the bottom left point, and w is the width, and h is the height. That's how we define a rectangle in OpenCV. Then you have the image rect equals to image array, and we crop it. So always when we crop it, we start by the y value. So we just do y. So we want the y coordinate of the starting point and the y plus the height, and same for the x. So we have x and x plus w. And of course, we have to resize it because when we will train the deep learning model, they all have to be in the same dimensions. So cv2.resize image image rectangle, and then we pass the tuple of the coordinates. So in that case, I will choose 100 and 100. Okay, so now we are ready to display and see what we get. So we don't want the image array, we want the image rectangle. Okay, so now let's run that. Okay, so we got an attribute error. That's just because of a misspelling. It should work now. And here we go. We have only the digit itself, and it's a bit stretchy because we have resized it to a particular size. But yeah, this is looking good. So now we are ready. Wait, first, let me comment this out. So now we are ready to do the data augmentation parts. So the first step of it is to slightly blur them, to blur the images slightly. Well, I have said before that we shouldn't resize like I did here, or we shouldn't blur them because they will not be binary anymore. But I think we have reached a point that we need actually the blurred images, even if we convert it to binary. And there is not much that different, to be honest. So we are still inside the loop. And what we will do is a for loop for blur in, actually blur value in range of let's say minus 30 to 30. So we will simply do image rectangle. Actually, we can name to something different like img. So img equals to cv2 dot Gaussian blur, and we have the image rectangle. So now we define sort of a short matrix to define how we want to plot them. So we should 7 and 7. And the value will be obviously blur value. Oops. And then we will display them again. Again, we need to change the image variable name. Alright, looks like we are ready to run, but before we run that, let me have a short Q&A session in this video. I was asked 2 questions in this channel, and unfortunately I didn't manage to do a Q&A video only, so I will answer here in the middle. You can skip this part if you want, if you really want to see what is the loop for that I have just written. Someone asked, I have a simple image with a range of 5 placements where the quantity is identified. How do I identify the biggest color type reds and say where is the X and Y and only for create an alert? Well, for color detection, yeah, it is possible. So the best way for doing that in OpenCV is to convert the image into HSV. And with that, you can set a color range for the red. You can type it in Google. It will give you pretty much a lot of answers. And then you can detect whether the area is red or not. And another one is, can you do a video that shows how to change the image on your webcam without any green screen, but just your camera? Yes, it is possible. For that, you can go to Zoom, create an account if you don't have one, and then set up a new meeting and enable the webcam, and you can choose a virtual background without any green screen. Well, that was pretty much for the Q&A thing. So now let's jump to the code. So we can now run this cell. Okay, so we have massive, right? Okay, so we have a bunch of ones. I'm scrolling a bit faster than the displaying of images. Right, so we have the 1, then we have the 2. Well, actually we have quite a lot for now, and I'm not gonna scroll down through all of them. So yeah. So that is one part of the data augmentation. So that is all for this video. In the next one, we will show the second part of the data augmentation, and we will also a new deep learning model. So the second part of the data augmentation will be making the digits a bit bolder or less bold, so we can have so we can be more precise, because obviously when we convert to binary, some of them are really bold like the one here, and some of them are really thin like the 2 here. That is much thinner than the one we saw above. Alright, give me a like if you enjoyed the video. Don't forget to subscribe for more tutorials like this, and see you next time.